Okay. If we're going to solve quadratics by completing a square, we first have to recognise what a perfect square looks like. So let's look at this one. When we say x plus 5 squared, we mean x plus 5 times x plus 5. Now expand that like you always expand binomials. X squared plus 5x plus another 5x plus 5 5s are 25. Collect your like terms, we end up with x squared plus 10x plus 25. Let's do another one. Let's go x minus 3 all squared. So it means x minus 3 times x minus 3. Now expand our binomials as normally. X times x, x squared, x times minus 3, minus 3x, minus 3 times x, minus 3x, minus 3 times minus 3 is plus 9. Always watching that minus sign. Then, collect like terms, x squared minus 9x, minus 6x plus 9. Okay, let's do one more. Let's do x minus 8 all squared. What does x minus 8 all squared mean? It means x minus 8 times x minus 8, square it out, x squared minus 8x minus 8x plus 64. Collect like terms, x squared minus 16x plus 64. Now hopefully what you're noticing is that there's a pattern to expanding perfect squares. When you expand a perfect square, you have the first term ends up squared, the last term ends up squared as well, noting the minus sign will turn into a plus, that's a plus, but x squared minus 3 gives you plus 9, that's an x squared, minus 8 gives you plus 64. And what happens in the middle? You end up with two lots of both terms. 2 times x times 5 is 10x. 2 times x times minus 3 gives me my minus 6x. 2 times x times minus 8 gives me my minus 16x. So you need to recognise that in order to be able to take the next step to use this for solving quadratics using completing the square.